So good morning everybody. Today I shall be discussing rectifiers and their uses. Assign a worksheet on this. So let's begin with the worksheet. So let's begin with the first question. It says that a rectifier is a. So it's basically an electronic circuit which is used to convert AC to DC. Next is ratio of frequency of input and output in half wave rectifier. This is 1. Ratio for full wave rectifier it is 2. Then we are being given a certain circuit of input voltage and we need to draw the output for half wave rectifier. So for half wave rectifier there is output only when it is forward biased. So it will give output only in the positive region, and in the negative region there will be no output. So that is the concept for half wave rectifier, and you can see that if this time period is t, then it is also periodic with the time period t. That means frequencies will be same for input and output. Next is the full wave rectifier. So full wave rectifier works on both positive and negative cycles, and we have output like this, and you can observe that its time period is half of the frequency is doubled. Next is center tap transformer is used, so it's used in the full wave rectifier. Next is draw circuit diagram of full wave rectifier with capacitor filter. So this is full wave rectifier, you just made the capacitor over here. And use of capacitor is offer infinite resistance for DC current, so DC component will pass away and it can be taken as the output. DC component means it can be used in DC based devices. Next is output of full wave rectifier, so it's a sort of not completely DC but a fluctuated type of DC like this, nearly DC we have. Next is draw logic symbol of Zener diode. So Zener diode is represented like this. It is used in the reverse bias and used as a voltage regulator, because as I discussed earlier, during the breakdown voltage, current increases substantially without any increase in voltage due to the bonding of the breaking electrons. So that simply explains the mechanism behind it. Next is IV characteristic. So it's just like same as that of some simple diode, but just the thing is it is extremely thin and highly doped. Next is draw circuit diagram of Zener diode when it is used in a circuit. So suppose this is the fluctuating input. We use a resistance R1, this is Zener, and we use a certain load over here. So when the input fluctuates, the voltage across Zener remains constant. So we can prevent the load from the fluctuating voltage. That simply explains the mechanism of load or using load over here. Next is an example of optoelectronic devices. Many of examples are there, like LEDs, the photodiodes, or the solar cells. So we can use them.